Students, in yesterday's lecture, we have started a new chapter that is Trigonometry 2. If you remember that in yesterday's lecture, we have proved one result regarding two compound angles that is cos A minus B. Now here, cos A minus B is equal to cos A into cos B plus cos A into cos B plus sine A into sine B, isn't it? Now, this is the result which we have seen in yesterday's lecture. That is, again I repeat it, cos A minus B is equal to cos A into cos B plus sine A into sine B. That is, here we have a negative sign to the left side, okay, that is LHS, and positive sign to the RHS. Okay, and cos A minus B is equal to cos A cos B, that is cos. Serial of the theta remains same in both the cases, that is AB sine cos sin. Now, using the same result, we are going to prove the next result. Which result? Here, for any two angles A and B, cos A plus B is equal to cos A cos B minus sin A sin B. Okay. Now, to the LHS we have plus sign and to the RHS we have minus sign. Result is same. If you compare both the results, the result is same, only sign get exchanged. Okay, here plus minus plus. Okay, the other things remains as it is. Okay, how to remember the results? Don't recite it, remember these results logically. Okay, then there will be no confusion. You can remember very easily the results, because there are so many results we will see further. So listen, see, observe carefully all the things from starting. Okay, so then you will be free from any type of burden or tension, and you will do not think about that how many formulas are there and blah blah blah. Not so many, very few, and so much easy formulas are there. Simple conversions. So, for cos A plus B, we have cos minus sin AB as it is. In place of A and B, we can also have C and D, X and Y, okay, as you wish. But for the convenience, we have generally or usually used the symbols for the angles A, B and C. Now let us prove this result. How we can prove this result? Now here let us have cos x minus y. The same result which we have proved here, cos A minus B is equal to, okay, and here we can prove the result our own way also. How we can prove it? Now see. Let us consider here cos A plus B is equal to, we can write the same term as cos A plus, sorry, A minus B. That is, this minus become again plus, isn't it? And the same term can be written as by using the formula which we have learned in last lecture, that is cos A cos minus B plus sin A into sin minus B, okay, is equal to cos A. Now, what is the result for cos minus theta? If you remember that in yesterday's lecture I have revised that the results for negative angle. Cos minus theta is equal to cos theta. That is, negative sign does not affect it. But sin minus theta is equal to minus sin theta. Isn't it? Therefore, cos A, cos B, and this minus sign and this minus sign, minus minus becomes plus, and we get sin A into sin B. Okay. Now what happened there? Actually, here plus sign is already there. Sorry. Okay, we can erase it. Here we have positive sign, by mistake it happened, and this plus due to this minus become minus, and we get the result that cos A plus B is equal to cos A cos B minus sin A sin B. Okay, and you can see that this is our required result. And which results we used here? We used the result of negative angle, that is cos minus theta is equal to cos theta, and sin minus theta is equal to minus sin theta. These results you have learned in previous chapter, okay? And the previous result, which result? That is here cos A minus B is equal to cos A cos B plus sin A sin B. Okay, by using this one we get the result. It is very easy to prove, and if it is asked in exam then you can easily prove it. Okay, now let us have a look over this one. Here let us consider the given profile. So cos x minus y is equal to cos x cos y plus sin x sin y. Okay, from yesterday's reference of yesterday's theorem. Now here if we put x is equal to a and y is equal to minus b, we get cos a minus this minus plus sign is adjusted here. Also you can see there minus minus become plus, minus minus b is equal to cos a cos minus b plus sin a sin minus b. But cos minus theta is equal to cos theta and sin minus theta is equal to minus sin theta. So my plus minus become minus, and hence we get eventually cos A plus B is equal to cos A cos B minus sin A sin B. So this is the next result. Now from the above two results we can have more results. Which more results we have? These results are very important results. These are okay. So try to remember all these results. Don't be afraid. Okay, there is no issue that it is too difficult or too much hard or anything else. So easy. Only you have to remember that angle is multiple of pi by 2 or pi only. Now here the first case angle is multiple of pi by 2, that is pi by 2 here only, cos pi by 2 minus theta. Now pi by 2 means what? 90 degree, isn't it? So obviously pi minus theta means this theta obviously lies in which quadrant? In first quadrant. Pi by 2 minus theta. Okay. Therefore, what is the result there? Cos pi by 2 minus theta is sin theta. that is cos reduces to sine. Isn't it? It is too easy. Only listen carefully, observe the results then one by one, and then you will easily understand that if we add or subtract theta in or from pi by 2, then cos reduces to sine, sine reduces to cos. Again, here tan reduces to cot and cot reduces to tan. Okay, only we have to consider the sign according to the position of theta. That is, we have to first determine that in which quadrant theta lies, and according to that quadrant we have to decide its sign. That is, either it is positive or negative, isn't it? So here let us see, cos pi by 2 minus theta is equal to sin theta. Now we can compare this result with what? Pi by 2 minus theta means a minus b. So a minus b. Therefore here let us have cos pi by 2 minus theta, that is pi by 2 is equal to say a and theta is equal to b. And if negative sign is to the LHS, then obviously positive sign to the RHS. And again same order, but only sign is there. Sin pi by 2 into sin theta. Now do you know of cos pi by 2? Yes, it is 0. Cos pi by 2 means cos 90 degree. And cos 90 degree is equal to 0. Sin pi by 2 means what? Sin 90 degree. Sin 90 degree is equal to 1 into sin theta as it is. But 0 into any real value is equal to 0. Plus 1 into sin theta. Sin theta. That is, obviously we have what? Sin theta means what? Cos pi by 2 minus theta is equal to sin theta. And since this theta lies in first quadrant, and in first quadrant all the trigonometric functions are positive, it has a positive sign. Okay. And by proof, theoretical proof also, it possesses a positive sign. You can see here. So in first quadrant all the trigonometric functions are positive. Okay. So you can see the proof given here also in the book. You can follow this proof also. If you like this proof, then you can, and if you like this one, then prefer this one. Doesn't matter. There is only the question of understanding. Okay. So here similarly we can prove that cos pi by 2 plus theta is equal to minus sin theta. How we can prove it? Now let us see. For your understanding purpose, I am going to prove this one also. So how we will prove this one? Let us see. Use the second result for cos a plus b. What is there? Cos pi by 2 plus theta is equal to, if to the LHS plus sign, then to the RHS we have negative sign, and cos sin sin, that is sin pi by 2 sin theta. Same terminologies are there. Okay. Here again cos pi by 2 0 into cos theta minus sin pi by 2 1 into sin theta, 0 into cos theta 0 minus 1 into sin theta minus sin theta, that is finally we have minus sin theta, that is cos pi by 2 plus theta is equal to minus sin theta. That is, now you can see plus pi by 2 theta. Pi by 2 means 90 degree. 90 degree, this whole get completed, and again we add theta. Okay, what is it? That is, what is the measure of theta? We don't know, but it exceeds this range, that is of 90 degree. That is, it lies in second quadrant, and in second quadrant cosine ratio is negative. Okay, though the result is sine, but we are actually finding the value of cosine, and cosine is negative in second quadrant. That's why cos pi by 2 plus theta have the same result sin theta, but it is negative in second quadrant. That's why it has a negative sign, that is minus sine theta. Therefore, here we can conclude that cos pi by 2 plus theta is equal to minus sine theta, and cos pi by 2 minus theta is equal to sine theta. Okay, it is in first quadrant and it is in second quadrant. And if we add theta to pi by 2 or subtract from pi by 2, cos reduces to sine. Remember this one. Okay, now here the next results are given. Okay, we will prove these results, but first we will prove the result for sin a plus b, sin a minus b. Then it will be convenient to these results, or we can prove in another way also. So which is the another way to prove this result? So if we use the same result, that is pi by 2 minus theta, then also we can prove that sin pi by 2 minus theta is equal to cos theta. And here sin pi by 2 plus theta is also plus cos theta. You can see there, because sine ratio is positive in first quadrant as well as in second quadrant also. Therefore, here we can prove these two results also. Now, tan pi by 2 minus theta. Tan pi by 2 minus theta. Here, tan pi by 2 minus theta is equal to sine pi by 2 minus theta cos pi by 2 minus theta. Sin pi by 2 minus theta is equal to, you can see there, cos theta. And cos pi by 2 minus theta is equal to sin theta. Therefore, is equal to cot theta. Okay, by mistake it happened. I have already told you tan reduces to cot and cot reduces to tan. So tan pi by 2 minus theta is equal to cot theta. So remember these one and try to prove these results independently also. Okay, so here we will see in next session the next results.